Oh my God, what is this clutter? Clutter. Oh, I see. It's all about matter. So, Madhuri here to talk about matter. Matter, the synonym for which is also substance. And is there any substance that doesn't have mass or that does not occupy space? Obviously not. So, all the substances, or to say the matter around us, has a definite mass and occupies the space. Now, let's see more about the matter because we see so many matters all around. We are surrounded by matter all over again and again. But are they all same? Not at all. Then what? Matters can be solids, the way you saw in the first slide, can be liquids. Obviously, the most common example is water that we drink off and on, and the gases. Oh, the air that we breathe in. So, this matter exists in three different forms: solids, liquids, and gases. And very quickly, we'll talk about how do they differ. The main point, we know all of them occupy space and they all have mass of their own, but solids, they have definite shape, yes. And liquids, oh, they do not have the definite shape, but yes, they are generous enough to take the shape of any container where they are in. And gases, no ways. They don't want to limit their shape, neither they want to limit their volume or the space they occupy. Yes, they scatter themselves all around wherever, whatsoever space, the free space they get. But how is that? Maybe it depends on the components in solids, liquids, and gases. But then, what are the basic components of the solids, liquids, and gases? Obviously, they are the molecules. Yes, the molecules in solids are tightly arranged, very closely packed because they have strong bonds in between them, and it is the strong bonds of the molecules that give definite shape to the solids. But liquids, they have the bonding, of course, but little less than what we see in the solids. Since the bond, the force of attraction in amongst the molecules is little less as compared to solids, we can see liquids flowing easily all around, and we can also see that they occupy the space as well as they take the shape of the container, may it be a beaker, may it be a flask, or a glass, or a cup, whatever. And what about gases? Yeah, they have the molecules, but the intermolecular bonds very less, minimal to say. That is the reason they are scattered here and there all around in the room or all around in the available space. Can the solids change into liquids, and can liquids change into solids? Let's see. Yes, it seems. So, this change of the state of the matter from solids to liquids and liquids to solids is what we call as fusion. Though this word fusion is used in many other processes, but here when we talk about the change of the state, it is the fusion. Now, this fusion, how the fusion happens? Yeah, probably it's because of the heat. Heat. But does the temperature of the substances change when they change their state? I mean, if we want to change the ice into water, does the temperature of the ice change while it is being changed into water? No, not even water. When it changes into vapors, even the temperature of the water does not change while it is being changed into vapors. So, where does this heat go? Hey, that heat remains hidden. It remains hidden. So we call this as latent heat of fusion. Now we have to see where is it hidden. Yes, we know heat either in the form of energy or in the form of temperature. Yes, when the heat is around, it will either increase the temperature of, it will either increase the temperature, temperature of the objects. So temperature increases or it decreases the temperature of the objects. Or else we also know heat is a form of what? It is a form of energy. So what does this energy do? Energy means movement. Energy means movement or what we call as motion. So if we increase the heat, the motion, the speed of the motion increases. If we decrease the heat, the speed of the motion decreases. So here we are. When we are heating a solid substance, what are we doing? We are providing what? We are providing energy to the molecules of solids. Now, this energy is being absorbed by the bonds in between the molecules. As the bonds absorb this energy, what will they do? The bonds, the bonds will make the molecules move around here and there. And since the energy is being used for the motion of the molecules, there is no rise in the temperature. As there is no rise in the temperature, but the molecules are moving around, with the result the molecules start moving farther away from each other and they result in change of state, change of state from solids to liquids. So it is this heat, not this heat that changes solids into liquids, is called as the latent heat of fusion. Why latent? Because normally it is thought if heat is around, it will affect the temperature. But here the heat is not affecting the temperature. What is it affecting? It is affecting the state of matter by providing energy to the molecules. So that's what we know about latent heat of fusion. And the latent of heat of fusion definition you can form on your own. That is, it will be the amount of heat needed to change 1 kg of solid into liquid at the same temperature without increase in the temperature. That's what will the latent heat of fusion be. But then, is there any other term parallel to that? Yes, it is latent heat of vaporization. Similarly, it will be the heat that changes what? That changes liquid into gases. So, latent heat of vaporization will be the amount of heat needed to convert 1 kg or 1 liter of liquid into gases at the same what? At the same what? Obviously, it is same temperature. And what will happen to the pressure? Obviously, the pressure has to remain the same. Hope it's all clear. Bye. You can put your questions in the comment section. Thank you.